I want to take a few minutes and try and do a quick review of logs, which is short for logarithm. Once again, this is a calculus class, and logs are taught as part of algebra. So I assume all of you have had logs before, but it's easy to forget things you've learned previously in math. And in truth, logs are one of those topics where a lot of students in algebra don't really understand logs very well. So this is going to be a pretty quick summary, but maybe if you've had trouble with logs in the past, maybe some of the things I show you and examples I do will make it a bit more clear. I will do a little bit of teaching and then some examples. I will try and not take too long on this because logs is something you can spend a lot of time on trying to work through things. So I'm going to try and find a balance here. Let me first do just a high-level brief introduction. This right here in algebra was called an exponential equation. The key being, turns out the variable x is up as an exponent. So we call those exponential equations. Now, as it turns out, we can take any exponential equation and we can rewrite it. In other words, we can change the form of this equation, change the way it looks. We aren't really changing the equation, we're just changing the way it looks. And we can rewrite it as a log equation. Now, in a few minutes, we'll do some examples of how we can convert this. But for now, let me just show you as this equation written as a log equation would be this. Now, in the world of math, the way we pronounce this is log base 4 of 16 equals x. Log base 4 of 16 equals x. This is actually the same equation as 4 to the x equals 16. Now it looks different. It's actually the same equation. A very simple way in the world of math, very simple example of maybe the same kind of principle. What if you were asked to solve this problem? So this expression over here, the way I solve it is I factor out an x. These two expressions are identical, although they look different, right? Well, the same idea here. These two equations are the same, even though they look different. Now, what we're going to do in a little bit in this example, we started with an exponential equation and I wrote a log equation, but actually it works both ways. There are going to be times in math where we have a log equation and we're going to rewrite it as an exponential equation. And the reason we go back and forth is because oftentimes we're given a problem. Sometimes we're given a problem as an exponential equation, and the best way to solve it is to convert it to a log equation, and then we're able to solve it. And there'll be other problems where we're given a log equation, and the best way to solve it is to convert the log equation into an exponential equation. And we're going to see that with some of the examples. And it's not unlike this here. The best way to solve this equation was to factor and to write this differently. And once we factor, then this becomes pretty easy to solve. So let me take just a very brief minute and try and give you just the very, very basics of what's involved with logarithms. For example, whenever you write a log, whatever number here is called the base. So for example, I could write log base 4 of x. I can put any number here as my base. Log base 10 of x. Now let me quickly share with you one of the interesting features of logs. Log base 10 of x is almost like a special log. When the base is 10, it's special. And the way I sometimes describe it in class, remember back when we were doing radicals? So maybe you have square root of 9. What if I were to write the cube root of 8? When I do the cube root, I put the 3 up here, right? Well, when I have a square root of 9, you know what, really? There's really a 2 there. But in the world of math, because square roots are so common, I think they just decide, you know what? If there's no number up here, then we know it's really a 2. So when you write a square root, you never put the 2 here. However, all the rest of the roots, you've got to put the number. Well, the same idea happens with logs. You know what the special log here is? Log base 10. That's the most common log we use. Matter of fact, you know what I did? I just said the word. Whenever the log is 10, whenever the base is 10, they don't write the 10. So whenever you see a log without a number down here, you know there's really a 10. And as a matter of fact, they give this a name. They actually call it common log. So when your base is a 10, you don't write the 10 here, and we even call it the common log. If the log is anything else other than a 10, then the base is written. So this is log base 7 of x. Now, there's one more special log, which just makes things even more interesting, or maybe for some of you confusing, if you've had logs and you remember logs. There's a special number in math. In the world of math, there are a few special numbers. Let me give you an example. You know, when you're doing geometry and when you're doing, say, you have a circle and you're going to find the area of a circle, it's pi r squared, right? Where r is like the radius of the circle. What is this pi here? That pi is actually a number. Normally we just call it 3.14, but it actually goes on forever. Well, this pi is a special number in math. You know what? There's another special number in math, and that's the value of E. You remember E, whenever you see E in math, that's also really a number. And in the world of math, E is like 2.72 approximately. Once again, it goes on and on. So just like pi is 3.14, in the world of math, when you see the letter E, it really represents a number. So now what they do is, oftentimes you will want to take the log, except you want to take the log base E. It's almost like the log of base 2.72. Once again, in your mind, you've got to remind yourself E is actually just a number. Special number, but it is a number. Now, once again, in the world of logs, log base 10, excuse me, is used a lot, but also log base E is also used a lot. These are the two most used logs. Now, what they've done in the world of math, just to make life interesting, whenever they have log base E of X, they decided to give this a different name. And now you've probably seen this. They call it ln of X, or the way you pronounce this. This is called the natural log of X. Because actually E is also called, when we have an exponential equation like this, this is called the natural exponential equation. So they use this word natural when we have this E involved. So really there's two sort of special logs. Log base 10, we just don't write a base, and it's called the common log. And then log base E, we don't write log base E, we write natural log of X. As a matter of fact, what's interesting is, I have a pretty old calculator. Some of you may have fancy calculators, but a lot of calculators, if you look at some of these keys, look here, log, log. This is the key you're going to press if you're trying to take the base 10 log or the common log of a number. But look what's next to it, ln. This is the natural log. But you know what? There are no other log keys on this computer. So it's almost like, if you look at this, of all these potential logs, log base 4, log base 10, log base 7, log base E, they decided on the calculator, they're going to give you the ability to work out problems to do calculations with these two logs. Log base 4, log base 7, I could not use my calculator if I wanted to do a calculation. Now, there are maybe fancier or more expensive calculators that do include other bases. But a lot of calculators, probably most calculators to this day, you only have the ability to do common log and natural log. So that's also interesting. When we do some homework problems in a few minutes, or some example problems, we'll be having to use these keys to do some calculations. All right, so that's introduction to the really basics of logs. Now I should cover one more thing that can become important. There are some special logs. So how about the log of 1? So this is common log, log base 10 of 1. And just for fun, I'll also do natural log of 1. Now you could grab your calculator to see what this is. So for my calculator, I would enter a 1, and then I'm going to hit my common log key. The common log of 1, or log base 10 of 1, is 0. And as it turns out, if I do the natural log, it's also 0. So actually, in the future, you won't really use your calculator for this. One good thing to remember is whenever you have the log of 1, any log, any base, log with any base of 1 is 0. Now here's another interesting fact. When we're looking to take the log of numbers or the natural log, the number inside here it has to be a positive number. Or another way of saying it, I cannot take the log of a negative number. Let me give you another example in math, right? Remember the rule about square roots? Square root of 9 is 3. What is the square root of negative 9? Well, it's undefined. What does that mean? That means I cannot have a negative number under a square root. It's undefined. It's impossible. Well, you know what? If I say log base 10, and maybe I will put 100 in here. Now I know the answer to this, but just for fun, I'll grab my calculator. I'll put in 100 and then take the common log. That's 2. What happens if I try and take the common log of negative 100? So I put in 100, I put the negative, hit the common log key. Error means undefined. So it's almost like square roots, right? You can't have a negative number under the square root. Well, with logs, any kind of log, natural log, if I were to take log base 4 of negative 1, any negative number inside of a log is undefined. One final point. What happens when you take the square root of 0? Square root of 0 is actually 0. What happens if you take the log of 0? Now I can tell you the answer, but just for fun, here's a 0. I hit the log key, still undefined. And that's why up here I said, anytime you're taking the log of a number, the number here has to be a positive number. It can't be 0 and it can't be negative. Has to be a positive number. Just for fun, what if I take a very, very small positive number, 0.0001. So 0.0001, I hit the log key. It's interesting, gives me a negative number, but it does give me an answer. Now we won't go into why this is negative, but the point is it does give me an answer. However, I cannot take the log of 0. I cannot take the log of negative numbers. All right, that was a very brief summary of the highlights of logs. Now what I want to do is take a minute, because it's very important. I'm going to show you how I learned to go back and forth between these two kinds of equations, because that's really the whole key to solving problems involving logs. And the way I'm going to show you is just what worked for me, how I tried to find the simplest way for me to understand it. And that's what I'm going to show you. And if you have another way to convert these back and forth, by all means keep doing it, as long as you do it correctly. Doesn't really matter what method you use, as long as you can do it properly. So let's start out with an exponential equation. This one, of the two things I'm going to show, this one I think is probably a little more complicated. So I'm given this exponential equation, and I'm asked to rewrite it as a log equation. Here's what I do. The key is, as an exponential, 4 is my base, x is the exponent, and the 16 is this number. The key is, what I'm going to do is I'm going to take the log of both sides of this equation. It's almost like in the world of math, you know. You could do anything you want to an equation as long as you do the same thing on both sides. So I'm going to take the log of both sides. But also, I want the base of my log to be the same as the base of this exponent. So if I got 4 to the x here, I actually want to take log base 4 of both sides. Now, the reason I do that is because there's this very special property of logs, and here it is. If I'm taking the log of an exponent, right? So this is an exponential sort of function. I'm taking the log. If the base of my log is the same as the base of this exponential function, you know what this whole thing equals? It just equals whatever the exponent is. So log base 4 of 4 to the x equals x. So you know what I've done? I've now converted this exponential equation into a log equation, because now you see here's this log. Let's do another example. How about common log of oh, sorry, I want to start with a an exponential equation, and I want to rewrite this as a log equation. So I'm going to take the log of both sides, but I'm going to look at the base of my exponent. Since it's a 10 here, I want to take the log of both sides, but I want my log to be log base 10. Now it's a little tricky here because there's nothing here. The base is really a 10, right? Right, when the base is a 10, I don't write it here. So this is log base 10 of both sides. Now log base 10 of 10 to the x, since the base of my log and the base of my exponential function is the same, this side just equals my exponent. And then over here, I have log base 10 of 500. Let's do one more. How about let's do something with our natural exponential function. E to the x equals 10. I want to rewrite this as a log equation. Here's my exponent. My base is e, right? E is a number like 2.7. So what I'm going to do is I'm going to take the log of both sides, and I want the base of my log to be e. Now someone might think, oh, log base e and log base c. Well, we don't really write log base c, right? Instead, we write natural log of e to the x, natural log of 10. Right? Natural log means log base e. So the base of my log is the same as the base of my exponential function. So this side equals x. So e to the x, I'm going to rewrite my exponential function, e to the x equals 10. Rewritten as a log equation is x equals natural log of 10. Now let's go the other way. So now, how about if I have log base 4 of 60 equals x, and I want to rewrite this as an exponential equation. In other words, logs should be gone. Now here's the method I use for this. I call this sort of and I discovered this a few years ago, and I just think it's a really easy way to do this conversion. I call the circle method because there's a process you go through. It's almost like you make a circle. You always start with the base of your log, and you write it just like a normal number. And then what you do is you go to the other side of your equation. You go across the equal sign, and whatever is here, whatever's on the other side, that becomes the exponent of what I just wrote down. So once again, you start with the base of your log, you write that as a number. You go to the other side, whatever's over here becomes your exponent. And then you go back again to the other side. And you write equals whatever is inside your original log. So it's almost like you make a circle. You start here, you go to the other side of the equal sign, then you come back, and then boom, there is your exponential equation. So what if we have something like, how about, I'm making up this problem as I go. How about, so we're given this log equation. It's interesting how my variable x is the base of my log. But anyways, I want to rewrite this as a exponential equation. You start with your base, go to the other side. So here's, start with my base, write that. Go to the other side, the 3 becomes the exponent. Then you go back to the other side, equals 8. So log base x of 8 equals 3 can be written as x cubed equals 8. So those are the two methods I use to go back and forth between log equations and exponential equations. And now we're going to actually work out some example problems, and you're going to see how we use a lot of this stuff we just talked about. So now I'm going to work some problems, and these are just like a lot of the problems you're going to see in the homework that you're going to do for online. Matter of fact, all these problems are, we're asked to solve the equation. So in other words, no, sorry. These first problems are not solving. These first problems are, they want you to rewrite this as a log equation. So it's an exponential equation, res log equation. Okay, if we're going to do what I showed you, since my base of my exponential function is a 10, I'm going to take log base 10 of both sides. Now log base 10 of 10 cubed, right? The base of the log and the base exponential equation are the same. So you just end up with your exponent. So 3 equals log x. Another one. How about e to the x equals 5, and they want to write this as a log equation. Now, hopefully you realize that since we're using e here, our log equation is actually probably going to be a natural log equation, but it's still a log equation. So what's my base here? My base is e, so I'm going to take the log base e of both sides, which we call the natural log. Now, natural log of e to the x, you can think of this as log base e of e to the x. The base of my log and the base of the exponential equation is the same, so I'm left with just the exponent. So e to the x equals 5 is the same as x equals natural log 5. Now, let's do a couple more problems where we go the other way. So here, we're given a log equation. And we want to rewrite this as an exponential equation. So when you start with a log equation, use the circle method, right? Start with the base of your log. Go to the other side, which is your exponent. Then you go back to the original side, and you write it here. So log base 4 of 64 equals 3 is the same thing as 4 to the third equals 64. Let's do another example. It's even a little more complicated, maybe because the numbers look a little messier, but you just use the same techniques. Log base 16 of 8 equals 3/4. I want to rewrite this as an exponential equation. Start with the base of your log. Go to the other side, which becomes your exponent. Then you go back to the original side. 16 to the 3/4 equals 8. All right, now the last thing we're going to do is we're going to solve some equations. So we're going to solve some equations, and you're going to notice when I solve these equations, some problems, they will give me an equation with a log, and the way I'm going to solve it is I'm going to convert that equation to an exponential equation, and then I can solve it. And then other times they will give me an exponential equation, and the way I'm going to solve it is convert it to a log equation. So you'll see how it works. So I've got like maybe 6 problems here. So you could get the hang of it pretty fast. Log base 2 of y equals 4. So we want to solve for y. I'm going to get a number for y. What's the solution? What number can I plug in for y that makes this equation true? The way I'm going to solve y is I'm going to convert this log equation into an exponential equation. So that's what we do almost all the time. If you're given a log equation and you're trying to solve it, usually the easiest and best way to solve it is to convert it to an exponential equation, right? So I start with the base of my log. I go over here, so 2 to the 4th, and I come back here, and look what I've done. This started out, I actually don't know how to solve this equation. Log base 2 of y equals 4, solve for y. I don't have any idea. I can't do it on my calculator. I don't know what I would do. But look what happened when I converted it to an exponential equation. Y equals 2 to the 4th. And if you want to sort of rewrite this, 2 to the 4th is what, 16. Look at, there's my solution. Y equals 16. I've solved that equation. How about let me make one up. Log base x so now my variable is the base of my log, and I want to solve for that. I don't know what does x equal. Oh, actually, I need to make sure. Sorry, needs to be log base x of 64 equals 3. Now, some of you are like log gurus. You may be able to look at this and right away know the answer, and that's great. But a lot of us have to have a method, some steps to go through to figure these out. I'm going to convert this to an exponential equation, which means I take the base of my log, I go across here, 3 becomes my exponent, and then I go back here, and it's going to equal 64. Now, to solve for this, you say, hey, is there a number that if I take the cube root, it equals 64? Well, how about 4? 4 times 4 is 16. 16 times 4 is 64. Looks like my solution is x equals 4. So you notice so far these two problems, the way I solved it is I converted the log equation into an exponential equation. Now I'll do one more. This one's a little tricky. You may see something like this in the homework. This involves a little bit of algebra. Here they say log base b of 9 equals 1/3. All right. Whether it's messy or not, I'm going to start out the same way. I'm going to convert this to an exponential equation. So I'm going to take b to the 1/3 equals 9. Although this actually is not a very nice problem. I think maybe I may have written it down wrong. Let me change this on the fly. Sorry. Let's instead make this 1/2. So b to the 1/2 equals 9. Now you realize 1/2, an exponent of 1/2 is the same thing as square root. So this is really saying the square root of what equals 9. Well, square root of 81 equals 9, right? So the solution is 81. All right, finally, let's do some problems the other way where we start out with an exponential equation and now some of you might know this answer in your head by looking at it, but let's go ahead and solve this by converting this to a log equation, and we'll go from there. So the key is, what's the base of my exponents of 3? So I'm going to take log base 3 of both sides. So log base 3 of 3 to the x is just x. This is actually not, this is good because this isn't really the way I want to solve this. You know why? This is a good example because I'm trying to figure out what is log base 3 of 81. So I say, well, let me go grab my calculator. But you know what the problem is with my calculator? I don't have a key that I can use for log base 3. Wow. So even though I've converted this to a log equation, I'm still sort of stuck. So what do? Well, the key is, when you're trying to solve a problem like this, I'm still going to use the same method, but there's going to be a little twist to it. I'm still going to take the log of both sides, but now I'm going to do log base 10 or common log. And I do that because if I ever have to use my calculator, I know I can use my calculator to figure out what the log is. Now here is one thing I haven't taught you yet, but is very important. So now's the time to teach it. In the past, over here, when the base of my log is the same as the base of the exponent, you get this nice thing where it just equals the exponent. I don't have that here. Just to make it very clear, I'm just going to stick the 10 in here, although you would never do this, but just because I'm trying to teach you this. The base of my log and the base of my exponent are not the same, so what do? Here's an interesting sort of rule and law about exponents and logs. You know what? If you have an exponential equation inside of a log, you know what's really sort of cool? you can take the exponent that's inside the log and you can move it to the front of the log and multiply it by the log. So what I end up having is wow. Let's talk about that again. There's this very cool rule with logs. So once again, what do we have? We're taking the log, and inside the log is an exponent. And this very cool rule with logs is if you have an exponential function inside the log, you can take the exponent part and you can move it in front of the log. So when I move the x in front of the log, it becomes x times log 3 equals log of 81. My whole goal was to solve for x. Now here, if I want to get x by itself to find the solution, I need to move this log 3 to the other side. What do? I just divide both sides by the log of 3. And then I actually have a solution. X is a log of 81 divided by the log of 3. Now I can actually grab my calculator, because my calculator, I can calculate log base 10 or common log bases. So I can actually figure out this number on my calculator. So I punch in the 81. I'm going to hit my log key. Then fractions like division, right? So I can divide and I can enter 3 and hit my log key. And then when I hit equal, turns out the answer is 4. X equals 4. So I've now solved this equation. Now here's what happens a lot. Let me do another problem that almost looks just like it. The answer is going to be a little bit different. The previous problem I said 3 to the x equals 81. How about 3 to the x equals 23? Solve for x. Well, I'm going to use the same method. Whenever you have your variable up there in the exponent, the way you solve this kind of equation is you convert it to a log equation. And the way I do that is I'm going to take the log of both sides. In this case, I'm going to do common log, log base 10. And I've got this special rule we just learned. If you're taking the log of an exponential function, I can move the exponent in front of the log. And now if I want to solve for x, I divide both sides by log 3. And once again, I can grab my calculator. 23 common log divided by 3 common log. Now in this case, it's not a nice number. I'll maybe write 2 digits, 2.85. So I'll round it off to 2.85. For these kinds of problems in your homework, they will tell you how many decimal places they want you to have in the answer. So there's the solution. Let's do an interesting one. Instead of 3 to the x equals 23, how about e to the x equals 23? Once again, don't get nervous. E is just a number. Although we don't write the number down, we call it e. I need to convert this to a log equation. I'm going to take the log of both sides. Now in this case, let me before I do this one, let's do this so you get the principle down. I have 3 to the x equals 23. What if I was given this problem? 10 to the x equals 23. Well, I'm going to follow the same steps I followed here. I'm going to take the log of both sides. I'm going to take common log of both sides. But what's interesting is, if you remember this, over here, because my base of my log was 10 and 3 is the base of this, I had to do this thing where I bring the exponent down front. But this actually is the old-fashioned, the very first kind of problems I had, right? Because the base of this log is 10, and I've got 10 to the x. So this is the original one where if the base of the log is the same as the base of our exponential function, it really makes it simple, because right away this becomes x. Now, for some of you who are wondering, if you do bring the x down front, you would have had this. But in the world of logs, if my base of my log is 10 and the base is what I'm taking the log of, in the world of logs, that equals 1. That's why when we do this problem, we sort of skip it and we just say, you know what? When the base of the log is the same as this here, it's just x. You know, really, I could have moved this in front and gotten this. But the rule of logs is log base 10 of 10 is 1. I say all that now to go back to this one. To make this problem simpler, I'm going to take the natural log of both sides. Since my base is here, and I know if I go back up here and I want an actual number, I could go to my calculator and I just have to type in 23 and hit my log key. 1.36. Down here, I'm going to take the natural log of both sides, and I'm okay with that. You know why? Because the natural log is on my calculator. So in this problem, if I have to take a natural log, I'm okay with that. So I take the natural log of both sides. Now you notice natural log of e to the x. What's the base of my natural log? It's almost like log base e of e to the x. What is that going to equal? Since the base here is the same as this, it's just x. So this thing is just x equals natural log of 23. And now I can go on my calculator and I can calculate the natural log of 23. 23 natural log, I better round up 3.14. All right, let's do a few more examples. How about e to the 3t equals 1200? So what you do anytime you have an exponential function equation like this, if I have my base as e, I'm going to always take the natural log of both sides because it just makes the math simpler. Because what's the natural log of e to the 3t? The base of the log is the same as the base of my exponential function. So I know this whole thing just equals 3t. And if I want to solve for t, what do I do? Divide both sides by 3. Now I need to do this calculation. the natural log of 1200 divided by 3. So put in 1200. Now I'm going to hit my natural log key. And then divide it by 3 equals 2.36. So t equals 2.36. And you know what? Just like solving any equation, maybe you say, well, let's check and see if this is correct. What do? You plug 2.36 in for t here, and you see if it works. So 3t, I'm saying t is 2.36 equals 1200. I'm going to see if this is true. So let's go ahead and grab my calculator. Let's calculate this and see if it's 1200. And then I will confirm I did it correctly. Now, I haven't gone over this yet, but now I'm trying to calculate the exponential function. So what my calculator, I'm going to multiply 3 times 2.36. And then I have a key that turns it into this exponential function. So 3 times 2.36 equals, and if you can see this little yellow right above the key is e to the x. So if it turns out I got to hit this little second key to activate this, if I do this and this, then it equals. Now here's what's interesting. It's 1187, really 1188. And it's like, wow, that's not the same number. That's true, but you know what the problem is? When I did this calculation, I rounded off. Just for fun, what if I don't round this off? And let's see what happens. So what if I say natural log of 1200 divided by 3? Now let's keep a bunch of these digits. It's a little crazy. 2.36. Matter of fact, I'm not going to write it down. I'm going to leave that number here. So this is t. I'm going to multiply it by 3. And then I'm going to convert it to an exponential equation. Let's see if it's a little bit closer to 1200. And look, it ends up being 1200. So in the world of math, oftentimes when you round off things and you cut out all these extra numbers, it can sort of affect your answers. So this is a correct answer, but it's an estimate because you rounded it off. If I left a whole bunch of digits, then I could actually prove the exact solution. All right, one more problem. And for this one, we're going to go back to starting with a log equation. 2 times natural log of x equals -4. I'm starting with a log equation. To solve this, I want to convert it into an exponential equation. But the way it works is, to do my little circle rule, I really need to have the natural log totally by itself. I can't have anything else on the other side. Right now, I've got this 2 here. So what I need to do is I need to move this 2 to the other side. And what do? I can divide both sides by 2. So -4 divided by 2 is -2. So now I have natural log of x equals -2. Now, when I have natural log by itself on one side, I can now convert this to an exponential equation using my circle rule. So what's my base here? It's e, right? So e to the -2 equals x. I can calculate this on my calculator. So I type in 2 and I make it negative. Now for my calculator, once again, if I go and activate this little e to the x key up here, then that becomes e to the -2. So that's what I'm going to do. And this becomes 0.135. I'll keep 3 digits. All right, so that was a quick review of logs, and some of these examples I did are what you're gonna see in the homework. Hopefully this helps, and you can solve all these problems.